The podcast solution to the Ka problem, number 3. Okay. Um, when you're doing a Ka problem, well, let's stop and do our ice table first. So the Ka expression here is going to be the concentration of the hydrogen ion multiplied by this OBr minus thing over HOBr. Now, let's remember that HBr is a strong acid, but HOBr is a weak acid. Okay? You would never see a strong acid on an equilibrium problem because we know that strong acids fully ionize in solution. So we're dealing with a weak acid. Let's do our ice table. ICE. We got H plus. Oops. Sorry about that. Erase that. Okay. We have HOBr. It's aqueous. So it's going to count. H plus ionizing to OBr minus. Question mark 0 0 minus X X X question mark X X. In an equilibrium problem that is Ka or Kb, we can assume that this is close to 0, so we're not going to count it. So we got our ice table set up. Okay, now before we start, this thing in a Ka problem is going to be our route to the pH or back. So let's remind ourselves from the acid-base smiley face that pH is the negative log of that H plus. In this case, that's going to be equal to the negative log of X, and H plus is going to be 10 to the minus pH. So just reminding ourselves that in Ka, it is that H plus that is a route into the acid-base smiley face. So it says calculate the initial concentration of HOBr, that's going to be question mark, in a solution that has a pH of 4.95. Okay, so Ka is going to be equal to X squared over question mark. Okay. We know that X equals H plus, which equals OBr minus. And we have the pH. So pH equals 4.95. So 10 to the minus 4.95 equals H plus, which equals X. So, and we have Ka as well. So we know now that Ka is 2.3 times 10 to the minus 9th. So 2.3 times 10 to the minus 9th is equal to X, which is equal to the H plus, we got by raising the pH to the negative 4.95. So 10 to the minus 4.95, we're actually going to square that because of that square right there over question mark. We're solving for question mark because they asked for the initial concentration of HOBr. There's initial, and there's HOBr, so the only thing we could be solving for is the question mark. We rearrange this equation, and we get 0.05 molar as the answer. Draw and label a titration curve for the addition of aqueous sodium hydroxide. So this is the sodium hydroxide aqueous that we are adding to the hypobromous acid. So in a titration curve, the pH is going to be on the left side. HOBr is a weak acid, so we're going to see a gradual increase to equivalence. And this is the buffer zone, where the pH is fairly consistent in that region. Now, one thing that I haven't talked about before is that the pH at equivalence normally would be 7, but when you're dealing with a weak acid, the equivalence point has a pH slightly greater than 7. So I'm just making a point of that right now. And they say use a dotted line on the same axis to sketch the curve for the titration of hydrochloric acid. Now, hydrochloric acid is a strong acid, and with a strong acid, you see those sharp increases. I'm going to do it in red, actually, also. Okay. So, titration of a strong acid is going to look like that, and the pH at equivalence for a strong acid is going to be actually equal to 7. So I'm going to do the differences and similarities between these two curves, and I want you guys to write this down. Okay, so for titration curves, and we're going to do a weak acid, strong acid. Okay, it's a sharp increase and pH equals 7 at the equivalence point. For this, we have a gradual increase and pH is greater than 7 at the equivalence point. Okay, so again, when we look at this problem, we do our case statement. Everybody counts because they're all aqueous. Okay. We do not count the change for an acid problem. We write Ka, which is equal to x squared over the question mark. Normally they give you this, but in this problem they asked you for it. They gave us the Ka right here. They did not give us the H plus directly, which is x, but they did give us the pH, and we know that H plus equals 10 to the minus pH. We're able to plug that into here, square it, and isolate the question mark for the answer. Titration curves. Weak acids show a gradual increase. Strong acids show a sharp increase at equivalence points. The pH is going to be a little bit greater than 7 for a weak acid, and it's going to be equal to 7 for a strong acid. Okay, guys, take care.